Chapter 11 is on counting methods and probability theory. 11.1 is the fundamental counting principle. So have you ever imagined what your life would be like if you won the lottery? Before you fantasize about becoming a person of leisure with a staff of obedient elves, think about this. The probability of winning top prize in the lottery is about the same as the probability of being struck by lightning. So it's early morning, you're groggy, and you have to select something to wear for your 8 a.m. class. Fortunately, your lecture wardrobe is rather limited. There's 2 pairs of jeans to choose from, 1 blue and 1 black, and 3 t-shirts, 1 tan, 1 yellow, and 1 blue. So the tree diagram shows that you can form 6 different outfits from your 2 pairs of jeans and your t-shirts. So we can count the bottom of our tree diagram. We've got 1 outfit, 2 outfits, 3 outfits, 4 outfits, 5, and 6 outfits. Each pair of jeans can be combined with one of the 3 t-shirts, and so we can use the fundamental counting principle to figure out how many combinations we have with 2 groups of items. If you can choose one item from a group of m items and a second item from a group of n items, then the total number of 2-item choices is just m times n. So the Greasy Spoon restaurant offers 6 appetizers and 14 main courses. And how many ways can a person order a 2-course meal? So we're picking 1 appetizer and 1 main course. And so using that fundamental counting principle, all we do is we multiply the choices together. So 6 times 14, and that gives me 84 options for a 2-course meal. This is the semester you will take your required psychology and social science courses. Because you decide to register early, there are 15 sections of psychology from which you can choose. Furthermore, there are 9 sections of social science that are available at times that do not conflict with those for psychology. In how many ways can you create 2 course schedules that satisfy the psychology social science requirement? And so we can't have them at the same time. And so I have to pick 1 psychology and 1 social science. And so all we do again is we multiply the 2 choices, 15 times 9, or we have 135 options for our class choices. Well, you forgot something in choosing your lecture wardrobe, shoes. So you have 2 pairs of sneakers to choose from, 1 black and 1 red. And so now our tree diagram has expanded. Now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I've got 12 outfits that I can form with 2 pairs of jeans, 3 t-shirts, and 2 pairs of sneakers. So unlike the earlier dilemma, now I'm dealing with 3 groups of items. And so we can just keep extending them to determine how many possible outcomes there are when there are 3 or more groups of items. So the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So we're just tacking on another group. So it works the same way. Next semester, you are planning to take 3 courses, Math, English, and Humanities. Based on time blocks and highly recommended professors, there are 8 sections of Math, 5 of English, and 4 of Humanities that you find suitable. Assuming there are no schedule conflicts, how many different 3-course schedules are possible? So again, we can only have 1 of each, and so we just multiply the options together. So we've got 8 times 5 times 4, and that gives me 160 options of 3-course schedules. Car manufacturers are now experimenting with lightweight three-wheel cars, designed for one person and considered ideal for city driving. Suppose you could order such a car with a choice of 9 possible colors, with or without air conditioning, electric or gas-powered, and with or without an onboard computer. In how many ways can this car be ordered with regard to these options? So we have 9 colors. We can have it either with or without air conditioning, so that's 2 options for air conditioning. We can have electric or gas powered, which again is 2 options as far as my energy for the car. And with or without an onboard computer. So again, we have 2 options in regards to the computer. So 9 times 2 times 2 times 2 gives me 72 different options for purchasing this car. You are taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices, with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you answer the questions? So let's just think about it. Question number 1 has 4 choices. Question number 2 also has 4 choices. And we can keep doing this 10 times. And so this is just 4 to the 10th power. And so we get a really big number, 1,048,576 options of how I can fill in my test. And that's a lot of options. So there are over 1 million ways of answering a 10-question multiple choice test. And there's only one way to answer the test and receive a perfect score. So the probability of guessing your way into a perfect score involves calculating the chance of getting a perfect score, which is just 1, from all 1,048,576 possible outcomes. So in short, prepare for the test and do not rely on guessing. And the last one. So telephone numbers in the United States begin with a 3-digit area code followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with a 0 or a 1. So in how many different telephone numbers are possible? So let's look at the area code first. We have 3 slots. And we know that the area code cannot begin with a 0 or 1. So that can be a 2, a 3, a 4, a 5, a 6, 7, 8, or 9. So that's 8 different options. We have no restrictions as far as the rest of the area code. So we can have a 0 or a 1 or those 8 digits from the first one. And so we have 10 possible options for the second and the third place. And so this is just the area code. Now we have a 7-digit local number. Again, the first digit cannot begin with a 0 or 1, so we have 8 choices, but the rest of these slots have all those numbers to choose from, so 10 choices. And so all we do, this is going to be your local telephone number. We just multiply these numbers together. So we multiply and we end up getting 6,400,000,000 possible phone numbers.